Okay, here's our next and final lesson on the ladder method for multiplication. We're going to move on to division after this, which is basically multiplication backwards, so more formal written methods for doing stuff with your times tables knowledge. So today we're going to solve problems involving multiplication using the ladder method. That means I would like to see some ladder methods in your working. Now most of these require a ladder method because they're basically a picture of one with bits missing. So first of all, let's just recap what a ladder method is. So let's put 645 times 9, and I'm going to put in my placeholders so I don't forget them. And I'm going to do 5 times 9 is 45, and 4 times 9 is 36, and 6 times 9 is 54, and 5 add nothing is 5, and 4 add 6 is 10, carry the 1, 3 add 4 add 1 is 8, and bring down the 5, we have 5,805. Just check my working because that was very quick. Yep, that all looks good to me. I can check with the 9 times tables. If 4 and 5 add up to 9, and 3 and 6 add up to 9, and 4 and 5 add up to 9. That means I know they're at least in the 9 times tables. Okay, so this is the first of the problems for today. The first question that everybody's going to have a go at. I have a multiplication and I have an answer. I don't have a question. I know that the questions include the digits 1, 2, 3 and 4. But I don't know the order. Now that could be 1, 2, 3 and 4. When I test that, put in my placeholders. 4 times 3 is 12, 4 times 2 is 8, and 4 times 1 is 4. Well, there's no way that's going to add up to 628. It's going to add up to 492, which is way too small. So, there's your first clue. It's not 1, 2, 3 times 4. You need to try these digits in a different order to see if you can work out the answer to that question. That's the first and most important question. Next, there are just 4 other missing digit numbers, multiplications. Each multiplication has got 1 missing digit, and you need to work out what it is. These should be easier than the last one, but there's 4 of them. So 5 times 5 is what? You need to write it in there. Work your way through. What's 7 times 5? And then what does that have to be for the last number to add up properly? 3 times something. What's going to go in here? Or more likely here, so that you end up with a 1 here. Okay? And then finally my big one. This is harder. So everybody has to do the first one. I've given you lots of clues. I would like everybody to have a go at the second one, but I understand that it is quite tricky. So if we get stuck on that, it's not the end of the world. As long as you've got the first one done and you've done the other work this week, you've done fine for your Year 4 stuff. The second level is a little bit trickier. I think a lot of you could give it a go. Should be alright, shouldn't be too bad. This last one I think is quite hard. I think some adults will get stuck on this one. But I put it in here just for you to have a go. Calling that 2 is probably wrong. So, the first problem is this is a 1-digit number times a 4-digit number. You've not done 1-digit numbers times 4-digit numbers because we couldn't risk going into a 5th digit because you're Year 4s and you're only supposed to go up to 9,999. However, we know this one, the answer is only 4 digits, so we're all right. Now, because it's a 4-digit number, I haven't just got a multiple of 10 and a multiple of 100. I've got a multiple of 1,000. 4 times something will go in there, 4 times something will go in there, 4 times something will go in there, and 4 times something will go in there. Now, I'll give you a hint to get you started. Let's think about the letter A. 4 times something has got to go in this box. But that box is only 1 digit long. So how many 4 times tables are there that have only got a 1-digit answer? Well, there's 4 times 1, which is 4, and 4 times 2, which is 8, and there's 4 times 3, well, that's 12. That's already too big. So A can only be 1 or 2. Okay. Well, A appears more than once. A might be here, but A is also here. And if it's a 1 or 2 up there, it's got to be a 1 or 2 down there. So 4 times something has a 2 at the bottom, or a 1. Well, what are the possibilities? The 4 times tables goes 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, and you can't have times 10 because it's a 1-digit number. Well, how many of those actually end in a 1 or a 2? That does, and that does. None of them end in a 1. So that digit there cannot be a 1, it must be a 2. So the first thing that you know for sure is that A is definitely a 2. And then you need to work on from there. Now, like I said, this is tricky. This is only here as an absolute challenge. If you really want to give it a go, do not get stressed about it. Do not spend ages on it. Do not worry about it if you get stuck on it. The first question is your question. That's our one to see whether you really have understood ladder method multiplication. The second set of questions are there because I think they're a bit of a challenge and I think most of you can do them. The third one is literally my big challenge. Okay, see if you can give it a go. You might even find some older brothers and sisters or other family members who like a bit of a math puzzle might want to do that one with you. Okay, any problems, let me know, and have fun with that one.